हेलो एवरीवन, हाउ आर यू डूइंग? ऑल आर गुड? सभी लोग बढ़िया, सभी अच्छे हैं? ऑल आर सेफ? दैट्स गुड. कैसे हो आप लोग का पढ़ाई? सब बढ़िया? सुपर सुपर, दैट्स गुड. My name is Mahesh. If you're new to this channel, this is SMR Online Physics, an online platform for learning physics for young students. All right. So here I'm going to discuss about the problem solving part on spherical mirrors. So this is a series continuation going on where I've been discussing about the reflection of light part by mirrors. First of all, we did for plane mirrors, then we did for spherical mirrors, and this is the part 2 of problem solving. All right. So today we are going to discuss some super 5 excellent problems. Okay. Let us do that. Are we ready for the problem solving part? Say cheers. Yes. Let's get started. Here comes the question number 1. A particle goes in a circle of radius 2 centimeters. A concave mirror of focal length 20 centimeters is placed with its principal axis passing through the center of the circle and perpendicular to its plane. The distance between the pole of the mirror and the center of the circle is 30 centimeters. So we have to calculate the radius of the circle formed by the image. So that is the question, guys. So let us get started. Go through the questions carefully, and I wish that you just pause the video here and try to solve it on your own as much as possible. If not, yes, the solution is always with you. All right, let's do it. The solution to question number 1. Let us read the question carefully. This question is definitely related with concave mirror. So I will write given for concave mirror. So we have noted down which mirror the question is actually dealing with. All right. So here it says there is a concave mirror of focal length 20 centimeters. So let me draw a diagram for my clarity of understanding the problem. That is the concave mirror. This is my principal axis. I'm marking the necessary important points like PFC. It says that the focal length of the mirror is 20 centimeters. So let's do it. This is the focal length. This is given as 20 centimeters. I'm writing all the numbers, all the distances without any bothering of sign conventions. So it also means that the radius of curvature for this mirror has to be double of focal length. We already know that. So it has to be equal to 40 centimeters. All right. That's good. Okay. What is the question talking about? So there is a particle which is actually going in a circle whose radius is 2 centimeters. All right. And is placed with the principal axis, and the center of the circle is perpendicular to the plane. Okay. So once, my dear students, the question is clear, that you have understood it, try to visualize it as much as possible on the paper. Okay. It says that the distance between the pole of the mirror and the center of the circle is 30 centimeters. So it is at 30 centimeters away. So it clearly means that the distance of the circle is greater than 20, lesser than 40. So this is where it is. So that is the center of the circle. So there is a circle. This is a 3D visualization. It will be difficult to draw it on the board. I hope you understand. The circle is actually facing the mirror, and there is a particle which is moving in this circle. And the radius of the circle is given to be as r equals 2 centimeters. So in this case, the radius can be also taken as the height of a certain thing. So the height is 2 centimeters. All right. So what we need to calculate? Calculate the radius of the circle formed by the image. So definitely, if something is kept in front of a mirror, the image is definitely going to be formed. So let us find out what would be the radius of that image formed. All right. You can definitely pause here also and try it for yourself. All right. Okay, good. So let me do it. The radius is this, and the distance of the center of the circle is given to be as 30 centimeters. My dear students, I am very sure you are perfect with your ray diagrams, the image formation by concave mirrors. So it very clearly looks like the object in the question is between C and F. So whenever an object is between C and F, the image goes beyond C and the image is going to be magnified. So we may even guess it like, we can even guess the image size is going to be greater than 2 centimeters. I mean to say the radius of the image of the circle is going to be greater than 2 centimeters. So let us do it. So here I will write the data U, object distance, that is left of the pole, that is minus 30 centimeters. Good. Focal length is needed, so I write minus 20 centimeters. So I'd like to first of all know where this entire circle's image is going to be formed. I mean to say, let me first of all calculate the image distance using the mirror formula. So we need the image distance. So using the mirror formula, 1 by V plus 1 by U equals 1 by F. Let me do it. 1 by V equals 1 by F minus 1 by U. Definitely all can solve this once the conditions are clear to you. This is minus 20, this is plus 30. I have directly written that plus, okay? I hope you are clear that this minus is going to make it plus. Alright, good. So let us see, 1 by V equals, take the LCM of 20 and 30. So it's going to be 6C there, minus 3 plus 2, so the result is minus 1 by 60. So we will come to know that the image of the circle is going to form at a distance of 60 centimeters from the pole of the mirror. Guys, it's very hot over here. Excuse me for that sweat on my face. Okay, this is minus 60 centimeters, all good. So the image is definitely, as we predicted, going to be formed beyond C, and that is going to be 40 plus 20, somewhere here. Alright. So now I would like to know what would be the radius of that image circle. So for that, assuming this R as the height of the given object, so we can write H dash by H should be equal to minus V by U. The problem at the beginning might have sounded a bit tricky, but now you see, once you visualize it, it becomes easier. So H dash equals minus V by U multiplied with H, and put in the substitution correctly. V, we have got it as minus 60 centimeters. So let us put it as minus 60 centimeters within the brackets. And there is U given to us as minus 30 centimeters. And there is height of the object, which is nothing in this case, it is the radius of the circle, that is 2 centimeters, which is positive always. So H dash comes out to be, say 32s, absolutely, minus 4 centimeters. So it means that there will be a circle formed which will be pretty large enough and which will be beyond C, and this radius is going to be around 4 centimeters. Hope the solution is very clear to all of you. Okay students, let's do question number 2 now. Okay, the question is, an object is placed between a plane mirror and a concave mirror of focal length 15 centimeters as shown in the figure. Find the position of the images after 2 reflections. Okay, so please do read the question and check the diagram carefully. All right. So what is the question telling us? We have, let me write down question number 2 solution. We have a concave mirror in combination with a plane mirror. Okay, it's a very good question to try. This is a concave mirror. Let me draw a diagram for it. And this is a given diagram with the question. What else is given to you? The focal length of this mirror is 15 centimeters. So let me mark down all the points, PFC. So this distance is given to you as 15 centimeters. So definitely the radius of curvature is going to be 30 centimeters. All good. Now look into the question. There are some distances already measured and put in the question itself, that the object is somewhere at 20 centimeters. So let us say if this is 15, this is 30. So the object is somewhere here, a point size object, this is here. Let us call it as O, and this object is at a distance of 20 centimeters from the pole of the mirror. So there is definitely, again you can see it's a concave mirror. The object is between the center and the focus. Alright. So definitely the image is going to be formed beyond C, but you'll find that there is a plane mirror also in the question. Where is the plane mirror? The plane mirror is shown to be 10 centimeters away. 10 centimeters means 20 plus 10, 30. Oh, exactly. The plane mirror is placed exactly at the center of curvature. That's it. So this is your plane mirror. So looking at these distances, this is already given in the question that from the object the plane mirror is at a distance of 10 centimeters. Everything clearly visible, right? So all the distances we have marked. This is the object. Plane mirror is also an excellent reflector. It has different properties in comparison to the properties of images formed by concave mirror. So how exactly to do this question? So the question is ready. We have understood the question. The diagram is ready, and I can clearly see that the plane mirror is at the center of curvature. So dear students, the question says find the position of the image of this point object after two reflections. Okay, means once from the plane mirror, again once from the concave mirror, because both are going to form the image. So I need to tell you after two reflections where would be the position of the image. So we could have considered here two cases also. First reflection happening from plane mirror, the second one happening from concave mirror. That will be case 1. Or we could have also said the first reflection taking place from the concave mirror, then the second reflection happening from the plane mirror. Let us quickly see this beautiful problem, what variation in the answers it is going to show us. Alright? Okay, considering case 1, the first reflection, let us take it. The first reflection happening from the plane mirror. So the second reflection will be taken place by the concave mirror. So definitely the students can pause the video and try it for yourself. Everything is now clear, you've understood the question. Give your best attempt and let us see what will be the answers. Alright? Come on, let's do it. So if this is the case, we know from plane mirror's properties, the object distance and the image distance will be exactly the same. So the object is 10 centimeters away from the plane mirror. So it means that if the first reflection is taking place from the plane mirror, the image in the plane mirror should be formed somewhere here. Let us call it as O dash. And this distance from the mirror, which is virtual image, also has to be exactly the same. That is 10 centimeters. So the image distance from the plane mirror should be equal to 10 centimeters, which I have shown in the diagram as O dash. This is the image. Now, my dear students, try to understand this virtual image of the real object O will now behave as an object for the concave mirror. So if I treat this O dash as an object for the concave mirror, then for the concave mirror, let me note it down. For the concave mirror, the object distance, please listen carefully. This virtual image formed by the plane mirror of this object O will be now treated as the object distance or the object for the concave mirror. In totality, the distance will be 30 plus 10, that is 40 centimeters away from the pole of the mirror. Alright. So we get U is equals to minus 40, if I am doing everything correct, 30 plus 10, 40, yeah, left side, so minus sign, Focal length of the concave mirror is minus 15 centimeters. Make it sure that everyone is confident about the sign conventions and ray diagrams. Otherwise, it's very difficult to move forward with solving these problems. Okay, you can see the signs automatically coming up because of the Cartesian sign conventions. Do watch the video if you are not at all sure about it. The link is provided in the descriptions below. Alright, okay. UF, then I will find out its image distance. So I need the image distance. So hence 1 by V plus 1 by U equals 1 by F. So you'll find 1 by V equals 1 by F minus 1 by U. So let me write it over here. 1 by V should be equal to 1 by F, that is minus 1 by 15, and minus becomes plus. Everyone is very sure about it. So plus 1 by 40. So 1 by V is equals to 15 and 40 LCM, if you want to take it like 15 and 40, 5 3s and 5 8s. So it is 120 over there. So you'll get minus 8 plus 3, that's equals to 1 by V equals minus 5 by 120, which gives me the image distance to be minus 120 by 5, that is minus 5 2s 10 and 5 4s 20. So after first two reflections, okay, the first reflection taken from the plane mirror case 1, the image distance is 10 centimeters away inside, and after the second reflection happens from the concave mirror, the final image is going to form to the left side of the pole at a distance of 24 centimeters. Means, if I take this case, the object was at 20 centimeters, so the image is going to be formed somewhere here, between this object and the plane mirror at a distance of 24 centimeters. I hope the case 1 is clear. Okay, let us move for case 2 for the same problem. Let me just clear it off. The same question, the same numbers. The first answer is minus 24. Remember that. And let us see what we get as a variation if I deal it with case number 2. Case 2, considering the first reflection from the concave mirror. Means first of all we will discuss about the image formation by the concave mirror, then we will talk about the image formation by the plane mirror. Alright. So if I look into the concave mirror case, do not get confused with the jungle of numbers over here. Alright, this is the object distance which is clearly mentioned in the diagram. So for the concave mirror, I am writing it here, U is equals to minus 20, and focal length doesn't change, it is minus 15. So now I have to find out the image distance using the mirror formula. Now we can really speed it up. 1 by V plus U. 1 by U is equals to 1 by F. So 1 by V should be equal to 1 by F minus 1 by U. So I should be getting 1 by V is equals to 1 by F, that is minus 15 minus again that, so it becomes plus 1 by 20. So what is the LCM of 15 and 20? Not a big issue at all. 5 3s and 5 4s. It is 60, so it is minus 4 plus 3. So you end up getting minus 60 centimeters. So if I treat the first reflection happening from the concave mirror, then for this point object which is at 20 centimeters away, the image forms at 60 centimeters to the left of the pole, somewhere here, 60. Huh? So radius of curvature was 30, so this is 30. So the image will be forming somewhere here now. In the second case, O dash, or let me call it as O double dash. This is extra 30 centimeters away from the plane of the mirror. Hope I'm clear, okay? The radius of curvature of the mirror itself is 30. I got the answer as 60, so additional 30, which is happening, which looks like inside the mirror. Now this object or this image of this object will be treated as an object for this plane mirror. So what I'm going to get now, if this is away from here 60, yes, 60 for the concave mirror, then by the plane mirror condition it should be another 30. So if it's 30 there, another 30. Hence by the plane mirror, if you look into the condition, 30, so another 30. By the plane mirror, the final image is going to be formed at the pole of the concave mirror. Yeah? Got it? You got it right? Absolutely. Wonderful. Those who got it right, okay? 30, another 30. That's it. And another 30 means the image should be forming right at the pole of the concave mirror. So these are the two possible cases we could have done it for this particular problem. Hope you loved it, and I am sure that I did not create any trouble for you. Hope I'm very clear. Okay? Thank you. Okay, dear students, let us move on to the third question. Okay? Hope you're able to solve it. Definitely there is no issue. Keep practicing. Stay motivated. Stay happy. Okay? So let's move on to the third question. The third question reads, a U-shaped wire is placed before a concave mirror having radius of curvature 20 centimeters as shown in the figure. Find the total length of the image. Alright, that is the question. So let us look into the diagram given below and try to attempt to solve it properly. A U-shaped wire. You're going to love this question. It's really going to open up your brain, okay? How to really do that. Definitely. Super smart, super intelligent kids. Pause the video, attempt it, crack it. So there's a concave mirror. This question also I picked for a concave mirror. So you have this concave mirror. You have this principal axis. Note down all the important terminology given in the question. The radius of curvature is 20 centimeters. So let us first of all note down the radius of the mirror is 20 centimeters, which automatically tells us the focal length of the mirror is 10 centimeters. A U-shaped wire, which is shown in the diagram, of the length of each side to be equal to 10 centimeters is placed at 30 centimeters. Okay, so it means that the object is placed beyond the center of curvature, another extra 30 there. So let us show it something like this. This is the U-shaped object of equal length of all the three sides. Okay, this is like extra 10 centimeters given to us. If I'm not wrong, that is there. 20 plus 10, yeah. So it has multiple ends, my dear students. Let us name it P, Q, R, S. Each side is also of length 10 centimeters. 10, 10, and this is also 10. Okay, this part is also 10. Let us do it really very neatly. It's going to help you, as I told you. All right. So you see that what is the technique here? That this end RS is actually at a distance of 20 plus 10, 30 centimeters away from the mirror. But this end PQ is not at the same distance. This end Q is actually at 20 plus 10 plus this extra 10. That is 40 centimeters away. So this is a bit far, this is a bit closer. So this is going to form a different kind of image, but the entire object is beyond C. So the image has to form between C and F. We know that from the ray diagrams. Alright. At the same time, the sides also have a length of 10 centimeters. So this is closer, this is a bit further away. Again, the sides are going to form in a different way. So the ultimate target of the question is to find out what is the total length of the image formed. Let's do it. Okay, so for the end RS, let us start with that. For the end RS, just excuse me. Alright, for the end RS, I'd like to write U is equals to 20 plus 10 is minus 30 centimeters. That is the object distance for this end. The focal length is minus 10 centimeters, applying all the correct sign dimensions. Let us quickly find out with the help of mirror formula where is the image going to form. So I find that is 1 by V is equals to 1 by minus 10, minus minus becomes 30. So we end up getting an answer 1 by v equals minus 3 plus 1, that is minus 2 by 30. So it tells us v is going to form at minus 15 centimeters. Means this end RS is going to form at 15 centimeters away from the pole. Means greater than 10, lesser than 20. So somewhere here, let us say. So this is where you're going to get your S prime. I'll make the entire height also once I know what about this height, because I know that if it was treated as a single object RS, then definitely the size would have been diminished. So let us quickly find out the height here. H dash by H will be equal to minus V by U. So you are going to get H dash equals minus V by U multiplied with H. So H dash equals minus V. Where is the V here? The image distance, we got minus 15. U, how much is the U for this? Yeah, minus 30. And the height of this RS. This height is equal to 10. So I find that the height of that RS is going to be, I lose this minus signs, 15 ones and 15 twos, and this is 2 5. So you are going to get minus 5 centimeters. Yes, as we have been predicting, the image is going to be slightly diminished. So if this is 10, the image is going to be a bit smaller. So I'll make it something like this. So this will become your R prime. Is that clear? Let us now talk about PQ part. Alright? In the meanwhile, if you want, you just note it down. Okay? So now for the end PQ, let us solve it quickly. And let me also note down the answers what I got right now here. The image distance for this S prime part is minus 15, and S prime R prime is equals to minus 5 centimeters. I just note down the answers. To find out the total length, we'll be requiring all these numbers. Now let us do for the end PQ. For the end PQ. Now you can see, my dear students, the point Q is actually at a distance of 20 plus 10 plus 10, that is 40 centimeters away. So I'll take the object distance as minus 40 centimeters. Focal length is minus 10. So I'll find out the image 1 by V equals 1 by F minus 1 by U. So I should get 1 by V equals 1 by F is minus 1 by 10, and this becomes plus 1 by 40. Alright. Are you picking it up? Great, come on. So 1 by V is equals to 40 here, minus 4 plus 1, that is minus 3 by 40. So I should get V is equal to minus 40 by 3 centimeters, which gives me an idea. This is around 3 ones 3, 3 threes, yeah, 13.33 centimeters approximately. Minus 13.33 centimeters it would be. Alright. So what does it mean now? Minus 13.33. It means that it's getting closer. This is 10, 13.33 from the pole of the mirror somewhere here. So since it is much more further away from the pole, it's going to get much more closer to the mirror. So somewhere here I should get the point QS, Q prime. Okay? The Q prime. Let us quickly calculate what would be the height of this part there. Definitely much more diminished. I think most of you easily guess it, or maybe you even got the answer. H dash by H equals minus V by U. So from here, the H dash, okay, my dear students, I'm trying to do it for PQ part right now. So H dash should be equal to minus V by U into H. Put in the numbers. Is that visible to all of you? Absolutely. Minus V, I'd love to take this fraction, not the decimal part, minus 40 by 3. U, object distance is minus 40 there. The height of that end is also 10 centimeters. So I lose this minus sign, and let us quickly see, this is actually 10. What we get, H dash equals 40 by 3, 40 gets cancelled, we are going to end up getting minus 10 by 3, that is around minus 3.33 centimeters. Is that clear? Alright. So it means that this end is going to become much more smaller, something like this. So let us call it as Q prime, P prime. Absolutely. So all I have to find out is what is this distance. Then I can find out the total length. How much is S prime, Q prime? Please, are we all doing good? Everything clear? Come on, come on. If you're liking it, do not forget to give a like to this video, okay? And if you're new to this channel, do subscribe it. Correct. Okay, right. Okay, now we would like to find out what is that S prime Q prime, because this length QS would be also slightly shortened up. Let us see how much it gets shortened up, and then we can find the total length. Okay, yes, I rubbed it off, but I remember for this, for VQ prime, we got the answer as minus 40 by 3 centimeters, correct? And P prime Q prime, we found it as minus 10 by 3 centimeters. So this is the data we collected from the previous two solutions. All right. So how much is that S prime Q prime is going to be? So we'll find out very easily. S prime Q prime should be equal to PS prime from pole to S prime minus pole to Q prime. So nothing to get puzzled out with this alphabets. S prime Q prime is very clear in the diagram. PS prime means the image distance of S prime, which I have noted over here, 15 centimeters. We need not use right now the sign convention, that is 15 centimeters away, and the other end was how much away? Minus 40. I'm just subtracting, okay? I'm not using the sign convention because I need only the length, not the sign. So I can write S prime Q prime is equals to, this is 45, this is 40, this is 3. So S prime Q prime, the length is only 5 by 3 centimeters. So my dear students, we are closing in to this problem. We know this length, now we know this length, now we know this length. So if you go back to the question, it is actually asking you find the total length of the image formed. Hence, the total length of the image formed of this U-shaped object is an addition of R prime S prime, S prime Q prime plus Q prime P prime. So I should get R prime S prime, we have noted here. Again, I don't bother to use sign convention because I'm only interested in the length part. This I found as 5 by 3 centimeters. And this length is around 10 by 3 centimeters. 3 looks common there. 15, 5, 10. So 15, 15, 30. 30 by 3. Oh, that's beautiful. That's beautiful. The total length of the image formed is going to be equal to 10 centimeters. What was the total length of the entire object? 10 plus 10 plus 10. 30 centimeters. Now the entire length has shrinked to 10 centimeters. That's it. Hope you enjoyed doing this problem, okay? Yeah, pause it and definitely note it down and do check it if you have any issues, okay? If you have any issues, please feel free to write it in the comments below. Yes, come on. Okay. Now let's move on to question number 4, okay? I hope definitely you are solving it proper, you're following me. So we'll go for question number 4, another beautiful problem I picked up for you, alright? So please check the question, note down the question. A concave mirror gives a real image magnified 4 times. When the object is moved 3 centimeters, the magnification of the real image is 3 times. Find the focal length of the mirror. Again, okay, the question is very clear. So let us try to solve it. You can definitely pause the video here and solve or attempt by yourself. Check it out. This is the 4th problem of this class. So what is the question talking about? We are dealing with a concave mirror. The focal length is not mentioned to you. This is P, this is F, and this is your C. Those are the regular terminology of the spherical mirror in this case. It says that magnification is originally 4 times the image is real, obtainable on screen. Okay, good. Now the object is moved 3 centimeters. So if you think about the ray diagrams and the properties of images, if I'm moving 3 centimeters, to which side I should move so that the magnification actually becomes lesser? It has become 3 times. So which side I should actually move it like? Should I move it towards the mirror, or should I move the object away from the mirror? Come on. Yes, those who got it right, okay? The answer will be, I have to move the object away from the mirror. As I move the object away from the mirror, the image will be forming towards the mirror and it becomes more and more diminished. Okay? Please check out the ray diagrams. Alright? Come on. So let us say case 1 given to us is m equals 4. But don't forget the very crucial sign minus, because the image formed is real. But I need to find the focal length of this mirror. So how can I move forward? I know m equals minus v by u. I also know m can be written as h dash by h. But I don't have the focal length connected to that. So let us create a formula where we can use the mirror formula 1 by v is equals 1 by f minus 1 by u, so that we can substitute for v in the magnification and get a new formula which will include that focal length also. So uf, so it is u minus f, so v is equals to uf by u minus f, hence we have m equals minus v by u. So I should be getting m equals minus v is this much, uf by u minus f by u. So we can write m equals minus uf remains on the top, u into u minus f, and I lose this u. So magnification is minus f by u minus f. My dear, those are very new to this. This is also another formula for magnification in terms of focal length and in terms of object distance. So definitely this is going to help us, hope so, for finding the focal length of this mirror. Alright, come on. You can pause it over here and just note it down, this derivation, which is going to be extremely helpful in various kinds of problems. So now we can move forward and do it something like this. M is given as minus 4. So in place of m, now I can write directly minus f by u minus f should be equal to minus 4. I lose this minus sign, so f should be equal to 4 times of u minus f. So f should be equal to 4 times of u minus 4 times of f. That is 5 times of f is 4 times of u. So from here, what was the original target in the question? Finding the focal length. So let us find out for u, so that we can substitute in the second case. It becomes 5 by 4 times of f. So this is what we get for the object distance when the image magnification was obtained to be 4 times. Alright. Now the question says the object is moved by 3 centimeters. As it is moved by 3 centimeters means there is an addition of 3 centimeters to the original position of the object. And the image magnification has reduced from 4 to 3 times. Alright. So let us do it. M is equals to 3. Again put a minus sign because the condition is real. Okay, the image is real. So let us start with this formula. Minus f by u minus f should be equal to minus 3. Is that clear? So this is minus out and you will be finding f is equal to 3 u minus f. So f is equals to 3u minus 3f, and I find it becomes 4f. It becomes 3 plus, sorry, something I did wrong here. What I did wrong was simply writing u is meaningless in this condition. So let us do it. M equals minus 3. So m equals minus 3. So I get This is minus f. Now be careful about it. U, the object has been moved by 3 centimeters. So in place of u, I will be writing u plus 3, addition of 3 centimeters, minus the f is equals minus 3. So I find this minus gets cancelled off, and f is equals 3 into u plus 3 minus f. So f is equals 3u plus 9 minus 3f. So 3f comes over to the left side, becomes 4f is equals to 3u plus 9. Now in place of 4f, you just put it here. This one you just put in here. The u, okay? So u is 5 by 4 times of f plus the 9. So you will be finding 3 into 5 is 15, 15 by 4. So if it comes on the left side, 4f minus 15 by 4f is equals to 9. So hence I find 16 minus 15, how much is that? If I take LCM, is f by 4 equals 9, hence focal length is equals to 36 centimeters. Is that visible to all of you? Absolutely. So the focal length of this mirror is 36 centimeters. Now even if you wanted to calculate the extra bit, you could have also known the object distance also, which is 5 by 4 times of 36, that is 4 nines. So object distance would have been 45 centimeters, which was actually not asked in the question. Our primary target was to find the focal length of the mirror, which in this case comes out to be 36 centimeters. Hope you loved the problem. Okay? Come on. Okay. We are done with the fourth, and this is the last problem for this video class. Okay? Hope I'm very clear. I'm making you comfortable in solving the problems. As I say, this is part 2 of the problem solving, slightly up. Okay? What is the question number 5? The question number 5 reads, oh yes, I have a convex mirror for you. A convex mirror of focal length 10 centimeters is shown in the figure below. A linear object AB of 5 centimeters is placed along the optical axis. The point B is at a distance 25 centimeters from the pole of the mirror. Calculate the size of the image formed of this object AB. Okay, my dear students, this question is about a convex mirror. Okay, so far we have been doing all about concave mirrors. So most of you definitely remember convex mirrors are mirrors which can only form virtual and diminished images. So maintaining the sign conventions, let me draw a visual picture of this convex mirror. This is your P, this is your pole, this is your center of curvature. What is given to us? There is an object lying along the optical axis. You can see the diagram in the question. I did not mark it AB there, so let us call this is A, this is your B. The length of the object is given to us as 5 centimeters. The object itself has a length of 5 centimeters, and the end B from the pole of the mirror is at a distance of 25 centimeters. Am I clear? Alright. So all I need to do is find the image size. The focal length is mentioned to be 10 centimeters. Alright. Is that clear? Okay. That's it. We did one such problem for concave mirror. Now we'll do it for convex. How to find out? You can easily see that the point B is a bit closer at a distance of 25, whereas point A is a bit further away, 25 plus 30, or 25 plus 5, that is 30. So for point B, the object distance will be minus 25 centimeters. Focal length is minus 10 centimeters. My dear students, definitely you can do it on your own, okay? Please pause it and try it. And then find the image distance for this, 1 by V, this, and if you put in the numbers, F, hey there, I did a mistake, it's not minus, for convex mirror, it's positive. There you go, there you go. It's easy to fall in the trap of sign conventions. Luckily we recovered on time. So we find the LCM of this, 5 2s and 5 5s. So it is like 50 and that is 2, so I get 7 by 50. So V is equals to 50 by 7 centimeters. That is roughly 7 point something, okay? 50 by 7 point. In convex mirrors, my dear students, the problems are always easy because the image is always going to be between the pole and the focus. As you can see here, the image of this end B is at a distance of 7.5 centimeters roughly. That is less than 10. It cannot go beyond the focus. So note down this answer. The position or the image distance for the end B is plus 50 by 7 centimeters in accordance with our signs. Alright. Now let us try for the end A. Definitely those who have got an idea, you have already solved it for A, I hope so. For the end A, if I have to really solve it, please take care. It's 25 plus the 5. So object distance will be now minus 30. Objects are on the left side. Focal length is plus 10 centimeters. Not to repeat the mistake. Now the image distance will be 1 by F minus 1 by U. Please note it, I am doing for the end A. So you're going to get this plus 1 by 30. So you're going to get the LCM is 30. So this is 3 plus 1, that is 4 by 30. Hence the image distance is 30 by 4. And definitely we find it like 15 by 2 centimeters. You can see that it is also 7.5 centimeters. Very, very close. The image has become linearly diminished, very much linearly diminished. Hence, I noted here, V for the end A is coming out as 15 by 2 centimeters. That's it. All we have to do is find the length. Find the final length of the image formed. So end B, which is closer, and end A, this is here, 7.15 by 2 centimeters, is the length of the image A prime, B prime. Alright, I call it here object AB, so I will call the image as A prime, B prime. So it should be all about what is the end A from the pole, how far it is, minus how far is the B end. So not to be confused, my dear students, it is the pole to the A end, A prime end, pole to the B prime end. I mean to say, this is the one, 15 by 2 minus the 15 by 7. Just you subtract the distances, you will find the length of the image. So this is 14. So you get 7 5s, and this is 105. This is 100. So you're going to get the length to be only 5 by 14 centimeters. So the original length of this object was 5 centimeters, but the image is only roughly of the length. If you divide and check it out, this is around 0.35 centimeters. It got highly diminished linearly. Okay, my dear students, I hope you enjoyed this session of solving problems with spherical mirrors. See you next in my new video class on a new topic. Till then, stay safe, stay healthy, keep rocking and keep enjoying physics. Thank you. See you once again. Bye.